Hi, today we are going to study max and min problem. We will first see how to solve this particular problem using brute force approach. Then we will see how to solve same problem using divide and conquer approach. So let us first understand what is max and min problem. Max and min problem is to find out maximum and minimum element from given array list. The number of list is provided in a form of array and we have to find out maximum element and minimum element from a list. Brute force approach to solve the same problem is working in such a way. Given a list of elements in an array format, we find out or we initialize two elements max and min as the first element of a list. So first element of a list is assigned to max as well as it is assigned to min. Then we will start comparing elements right from the second location. That is, the second element of a list is compared with max element. If that element is greater than max, our max must store the new or second element. Similar way, second element is also compared with min element. If the second element is lesser than min element, the second element must be stored inside min. And we keep on comparing these elements one by one unless and until we reach to the last element of the list. So after traversing a complete list of elements, we have max and min values within our variables or elements min and max namely. This is the basic way to find out maximum and minimum elements from the list. Let us see the simplest technique in detail. We initialize max variable and min variable as the first element of a list. That is, A of 1 is given to max as well as min variable. Right from the second element of the list, that is for I is equal to 2, going up to the last element of the list, that is up to n, what we have to do? We have to compare max variable with A of I element. If max is lesser than A of I element, then obviously A of I is greater than max. In that case, we must assign A of I to max. Second comparison we will do is for min. If min element is greater than A of I element, then we have to assign A of I element to min. Total number of comparisons required to find maximum and minimum element here are number of time loops works into how many comparisons we have done. So loop is initialized from 2 and going up to n. So total number of time loop is going to execute is n minus 1 time. And how many elementary comparisons are there? There are two statements. That means this loop is every time executing two comparisons at least. So number of steps over here within the for loop are 2 into n minus 1, which is equal to 2n minus 2. So in this way, the number of comparisons done are 2n minus 2. So the complexity of a given brute force approach of max min problem is big O of n. Let us now see divide and conquer approach or max min problem. Now in this particular case, we will consider one example. Say this example contains list of elements which are numbers. We first try to divide a given array list into two parts, that is from middle. So we have low index, we have high index. We will calculate midpoint of an array and we divide low to mid as one list and from mid plus 1 to high as our another list. We keep on dividing the steps or we keep on dividing or repeating the steps unless and until each list contains only one or two elements. because it would be easier for us to find maximum and minimum elements if there are only one element or there are two elements in our list. So let us keep on dividing the list. First we will consider left side sublist. So that would be divided again into halves from the middle. So from low to mid, one list will be generated. From mid plus 1 to high, another list will be generated. Now in this case, second list contains only two elements, so we need not to divide our right hand side list. We will keep on dividing the list which is having three elements. Now three elements are divided so that the left list contains two elements and right list contains only one element. Now in this particular case, my left side sublist is containing either two or one element. So let us move towards the right hand side. Towards the right sublist, there are four elements, so we also need to divide them so that each sublist contains minimum one or two elements. So there are in total four elements. We will divide it into halves from middle. So it would be get divided into 90 and 65 and another list will be 25 and 75 respectively. Now if you observe carefully, each leaves are having minimum one or two elements in it. Or we will start solving our sub-problem which is very small enough. So we will take an element or we will take very first list which is containing 50 and 40. We will make one comparison to find out which element is max and which element is min. So this will be max as 50 and min as 40. In our second sublist, where there is only one element, no comparison is required. Directly max and min will be an element itself. That is max is equal to minus 5 and min is also is equal to minus 5. We keep on repeating the same steps of two elements and one element on each sublist. So in third sublist, max is 45 and min is minus 8. In our fourth sublist, max is 90 and min is 65. In our last sublist, max is 75 and min is 25. So this is the solving the minimum size problem of the each subproblem. Now we will in a conquer stage. That means we will group the solution of two problems to get the solution of original problem. So we will work from bottom up manner. We will take two sublists and compare their max values. If the max value of these two sublists, whatever the maximum is, will become the new max of upper sublist. Similarly, we are going to compare two min values of two sublists. Any value which is the minimum out of two will become the new min of upper sublist. So let us apply the same procedure. We will combine 50, 40 and minus 5. We will first compare their min values and their max values. Max of left sublist is 50 and max of right sublist is minus 5. So out of 50 and minus 5, maximum value is 50. So for the top level sublist, maximum will be 50. Similarly, we will compare 40 and minus 5, that those are min values. Out of 40 and minus 5, the minimum value is minus 5 only. So for upper side sublist, minus 5 will be the new minimum value. So let us see, max is 50 and min is minus 5 for the upper list. Similarly, we are going to combine 50, 40, minus 5 and another sublist minus 8 and 45. We are going to compare their max element to find the new max of upper sublist and we are going to compare their min values to get the new min value of the upper sublist. Similarly, we will get new max as 50 and new min as minus 8. Now similar for the going one more upper level, we must have the solution of both these subproblems. So towards the right hand side of the 90 sub-error list, we don't have max and min. So we need to solve the from bottom up side. So towards the right, the bottom two lists are 90, 65 and another sublist is 25 and 75. We need to combine them in a proper or the same manner. So mu max will be 90 and mu min will be 25. Now to combine these two sublists to generate our original list, max will be now mu 90 and mu min will be now minus 8. So final values are 90 and minus 8 from a given list max and min value. Now let us see how algorithm for the same max and min divide and conquer approach will work. So max and min algorithm would require 4 inputs. Actually, those are 2 inputs and 2 values which will be carrying an answer. So two inputs are I and j index, which are the starting and ending index of an array list. Max and min are the two variables which are going to hold our answer. So here we first check I is equal to j. That is our very first condition. If starting index is equal to the ending index, we deduce that array element contains only one element in it. That means if there is only one element in a list or sublist, min and max both will be the element itself. So we assign an element a of I to min and max because I is equal to j. That is, starting index is equal to ending index. Now second, we will check whether I is equal to j minus 1. That is, our starting index is equal to ending index minus 1 or not. If this condition is satisfied, we are sure that sublist actually contains only 2 elements. So if there are only 2 elements, we have to make only one comparison to find out which element is maximum and which element is minimum. So inside this case, we are comparing A of I with A of j. If A of I is lesser than A of j, we say maximum is A of j and minimum is A of I. But if this condition is not true, reverse is possible. That is, maximum is A of I and minimum is A of j. So we have assigned or we have found out maximum and minimum when there is only one element in a list or where there are two elements in our sublist. The third case will include the number of elements in a list which are more than 2. So in our else part, when there are more than 2 elements in a list, we need to divide our list into halves right from mid position. So first step in this case is to obtain our mid location. Mid location is calculated as starting index plus last index divided by 2, that is equal to I plus j divided by 2. And we will call recursively this max-min algorithm for 2 times, that is from start to mid and from mid plus 1 to high. So that is called as max-min from I to comma mid for max and min, and max-min is also called from mid plus 1 to j for max and min. Now here we are assigning two variables, max and max new, min and min new. So on the recursive call completion, now we have two variables. One is max, another is max new. And we have another two variables, that is min and min new. We need to compare max and max new to find out which is the maximum out of these two. Whatever the maximum out of these two must be the max of original problem. So next step we will compare max with max new. If max is lesser than max new, the actual max must be max new. That means max is now storing value of max new. Same comparison must be done between min and min new. If min is greater than min new, min should be new min. So in that case, min is assigning a value of min new. So this way recursively algorithm would be called for each and every element sublist, and the answer would be stored inside two variables max and min. Let us now analyze the divide and conquer max min problem. In this particular list, if there is only one element in a given list, in a one step we directly get an answer. That means if there is only one value in a list, we directly say that value is maximum and that value is minimum. So steps required to calculate to get an answer for only one subproblem, that is t of 1 is equal to 1. If there are two elements in a list, what we do, we make only one comparison to get our max and min values. That means t of 2 is equal to 1 also. But if there are more than two elements in a list, that is t of n, we first have to divide this list into two equal parts, each of size n by 2 approximately. So that is equal to t of n is equal to 2t of n by 2. Plus we would also require two steps to compare max new and min with min new. So those two are the additional steps to get our final max and min values. So t of n would be 2t of n by 2 plus 2. Now we will solve. So this is our recurrence relation. That is t of n is equal to 2t of n by 2 plus 2 for all n greater than 2. And for t of 1, that is, and t of 2, we will require only one step or one comparison to get our final max and min values. Now let us analyze this recursive statement with the help of substitution method. So instead of n by 2, we are substituting n is equal to n by 2. So n by 2 will become ultimately n by 4. Our equation 2t of n by 2 plus 2 will now become 2 into 2 t of n by 4 plus 2 plus 2. That can be rewritten as, if I solve these brackets, our expression will be 4t of n by 4 plus 2 square plus 2. Again we will make substitution as n by 4 with n by 8. That is equal to 4 into 2 t of n by 8 plus 2 plus 2 square plus 2. That would be, the expression would be now 8 t of n by 8 plus 2 cube plus 2 square plus 2. Now this 8 can also be represented as 2 power, that is 2 cube t of n by 2 cube plus 2 cube plus 2 square plus 2. If we keep on substituting this term, our generalized term would be like 2 raised to k t of n by 2 raised to k plus 2 raised to k plus 2 raised to k minus 1 plus 2 raised to k minus 2 up to 2 raised to 1, that is equal to 2. Now let us make some substitution. Let us put n by 2 raised to k is equal to 2. So in this case, n will be 2 raised to k plus 1 and n by 2 would be 2 raised to k. So wherever the 2 raised to k term would appear in our original expression, we are going to substitute n by 2 in its place. And wherever the term n by 2 raised to k is appearing, we are going to substitute 2 at its place. So if we rewrite this equation, first term 2 raised to k into t of n by 2 raised to k will be n by 2 into t of 2. But the later terms, that is 2 raised to k plus 2 raised to k plus 1 plus 2 raised to k plus minus 2 up to 2 raised to 1 is actually written as a summation formula. That is summation of 2 raised to I, where I is ranging from 1 to k, which is also expanded as 2 raised to k plus 1 minus 2. So in place of this particular complete summation sign or this series, the direct expansion or direct substitution will be 2 raised to k plus 1 minus 2. But instead of 2 raised to k plus 1, we can directly make a substitution of n. So our equation would appear as n by 2 t of 2 plus n minus 2. So this will be generalized or this will be evaluated as 1.5n minus 2. So ultimately, the complexity of divide and conquer max-min algorithm is big O of n, and number of operations that are performed, elementary operations, are 1.5n minus 2. Thank you everyone for watching this video. This is Bunita Topia signing out.